Welcome to this comprehensive exploration of one of geometry's most fundamental principles, the sum of angles in a triangle. Today we'll discover why every triangle, regardless of its shape or size, has interior angles that always add up to exactly 180 degrees. Let me show you three different types of triangles. We have a scaling triangle, where all sides are different lengths, an isosceles triangle with two equal sides, and an equilateral triangle where all three sides are equal. Despite their different shapes and proportions, they all share the same remarkable property. Now watch as I add the angle measurements to each triangle. Notice how each triangle has three interior angles marked in degrees. The scaling triangle has angles of 70, 60, and 50 degrees. The isosceles triangle has angles of 80, 50, and 50 degrees. The equilateral triangle has three equal angles of 60 degrees each. Here's where the magic happens. When we add up the three angles in each triangle, something remarkable occurs. 70 plus 60 plus 50 equals 180 degrees. 80 plus 50 plus 50 also equals 180 degrees. And 60 plus 60 plus 60 equals 180 degrees. Every single triangle gives us the same total. This brings us to the triangle sum theorem, one of the most important principles in geometry. The theorem states that the sum of the interior angles of any triangle is always 180 degrees. This fundamental property holds true for every triangle in Euclidean geometry, regardless of the triangle's size, shape, or orientation. Throughout this video series, we'll explore why this theorem works, see visual proofs, learn about exterior angles, and solve practical problems using this fundamental principle. Understanding this concept will unlock your ability to solve countless geometric problems and deepen your appreciation for the elegant patterns in mathematics. The triangle sum theorem is one of the most fundamental principles in geometry. This theorem states that no matter what triangle you have, the sum of its three interior angles will always equal exactly 180 degrees. This means that if you measure the three angles inside any triangle and add them together, you will always get 180 degrees. We can write this mathematically as angle A plus angle B plus angle C equals 180 degrees. This theorem applies to all triangles, regardless of their shape. Here we have an acute triangle where all angles are less than 90 degrees. Notice that 60 plus 70 plus 50 equals exactly 180 degrees. We can verify this by adding the angles. 60 degrees plus 70 degrees plus 50 degrees equals 180 degrees. The theorem also works for right triangles, which have one 90-degree angle. In this right triangle, we have angles of 90, 30, and 60 degrees. Again, when we add these angles together, 90 plus 30 plus 60 equals 180 degrees. Even obtuse triangles, which have one angle greater than 90 degrees, follow this same rule. This obtuse triangle has angles of 30, 40, and 110 degrees. Once again, 30 plus 40 plus 110 equals exactly 180 degrees. Now that we've seen this theorem in action with different types of triangles, there are several important points to understand about why this theorem is so fundamental. First, this theorem works for all triangles in Euclidean geometry, which is the geometry we use in everyday life. It doesn't matter how the triangle is oriented, positioned, or what size it is. Second, this theorem serves as the foundation for many other geometric principles and proofs. Understanding this concept is essential for more advanced geometry topics. Finally, and perhaps most practically, this theorem allows us to find unknown angles in a triangle when we already know the measures of two angles. This makes it an incredibly useful tool for solving geometric problems. Remember, the triangle sum theorem states that the sum of the interior angles of any triangle always equals 180 degrees. This fundamental principle will be the basis for everything else we explore about triangles. Now we're going to visually prove why the triangle sum theorem works. This proof will show you exactly why the angles in any triangle must add up to 180 degrees. We start with any triangle. I've labeled the three interior angles as alpha, beta, and gamma. Our goal is to prove that alpha plus beta plus gamma equals 180 degrees. The first step in our proof is to draw a line parallel to the base of the triangle. This parallel line passes through vertex C, the vertex opposite to our base. Next, we extend the sides AC and BC of our triangle. These extended sides will act as transversals that cut through our parallel lines. Now we can remove these labels to focus on the angle relationships. When parallel lines are cut by transversals, we get special angle relationships. Here's where the magic happens. Because of the properties of parallel lines and transversals, we can identify corresponding angles and alternate interior angles that are equal to our original triangle angles. Notice that we now have angle alpha on the left side of the parallel line, angle gamma at vertex C, and angle beta on the right side of the parallel line. These three angles are arranged along our straight parallel line. Since these three angles lie along a straight line, they must form a straight angle. And we know that a straight angle measures exactly 180 degrees. But wait, these are exactly the same three angles from our original triangle. Alpha, beta, and gamma are the interior angles of triangle ABC. Therefore, we have proven that the sum of the interior angles of any triangle equals 180 degrees. This proof works for any triangle, whether it's acute, obtuse, or right-angled. The key insight is that parallel lines and transversals create angle relationships that allow us to rearrange the triangle's angles along a straight line. This geometric relationship is fundamental to understanding triangles and forms the basis for many other geometric theorems. Now that we understand interior angles, we need to explore another important concept: exterior angles of a triangle. These angles provide us with additional insights into triangle geometry. An exterior angle is formed when we extend one side of a triangle beyond a vertex. Watch as I extend side AB beyond vertex B to create an exterior angle. The exterior angle is the angle formed between the extended side and the adjacent side of the triangle. This angle is outside the triangle, which is why we call it an exterior angle. Now here's where it gets interesting. The exterior angle theorem states that an exterior angle of a triangle equals the sum of the two non-adjacent interior angles. Let me demonstrate this with our triangle. The two interior angles that are not adjacent to our exterior angle are angle A and angle C. According to the theorem, our exterior angle should equal angle A plus angle C. So we can write this relationship as a mathematical equation. The exterior angle at B equals angle A plus angle C. Now there's another important property of exterior angles. If we create exterior angles at all three vertices of our triangle, the sum of all three exterior angles will always equal 360 degrees. Let me extend all three sides of the triangle to show all three exterior angles. Watch as I create the complete picture. Now I can show all three exterior angles. Each exterior angle is formed between an extended side and the adjacent side of the triangle. Here's the remarkable fact. No matter what triangle you have, the sum of all three exterior angles is always exactly 360 degrees. This is true for any triangle: scalene, isosceles, or equilateral. This makes intuitive sense when you think about it. If you walk around the perimeter of any triangle and return to your starting point, you will have turned through a complete rotation of 360 degrees. Let me give you a concrete example to make this crystal clear. Consider a triangle where the interior angles are 60 degrees, 70 degrees, and 50 degrees. The exterior angles would be 180 minus each interior angle. So we get 120 degrees, 110 degrees, and 130 degrees respectively. And when we add these exterior angles together, 120 plus 110 plus 130 equals exactly 360 degrees, confirming our theorem. Understanding exterior angles gives us powerful tools for solving triangle problems. In our next examples, we'll see how to use both the exterior angle theorem and the 360-degree sum property to find unknown angles. Now we'll explore a very special type of triangle called an equiangular triangle. This is a triangle where all three interior angles are exactly equal to each other. Here we have an equiangular triangle. Notice how it appears perfectly symmetrical. This symmetry is the key to understanding its special properties. In an equiangular triangle, all three angles are equal. But what is the measure of each angle? We can find this using the triangle sum theorem we learned earlier. Since we know that the sum of angles in any triangle is 180 degrees, and in an equiangular triangle, all three angles are equal, we can set up a simple division problem. Because all angles are equal, we can divide 180 degrees by 3 to find the measure of each individual angle. This gives us 60 degrees for each angle. So every angle in an equiangular triangle measures exactly 60 degrees. Now we can replace those question marks with the actual angle measurements. Each angle is 60 degrees. There's something very special about equiangular triangles that makes them unique among all triangles. Equiangular triangles have a remarkable property. They are also equilateral. This means that not only are all the angles equal, but all the sides are equal in length as well. These small marks on each side indicate that all three sides have the same length. This perfect symmetry in both angles and sides makes equiangular triangles truly special. Watch what happens when we rotate this triangle. Because of its perfect symmetry, it looks identical at multiple positions. This is a unique property that no other triangle possesses. To summarize the key facts about equiangular triangles, each angle measures exactly 60 degrees. All sides are equal in length, and they have perfect three-way rotational symmetry. These properties make them the most balanced and symmetrical triangles possible. Equiangular triangles represent mathematical perfection in the world of triangles. Their unique combination of equal angles and equal sides makes them fundamental building blocks in geometry and appears frequently in nature, art, and architecture. We've reached the end of our comprehensive exploration of triangle angles. Throughout this video, we've built a solid foundation in one of geometry's most fundamental principles. The triangle sum theorem states that the sum of all interior angles in any triangle always equals exactly 180 degrees. This isn't just a mathematical curiosity, it's a fundamental truth that applies to every triangle, whether it's scalene, isosceles, or equilateral. We explored several key concepts that reinforce this theorem. We learned how to use visual proofs with parallel lines, discovered the exterior angle theorem, and practiced finding missing angles in various triangle configurations. Understanding triangle angles is crucial for your mathematical journey ahead. This knowledge forms the foundation for trigonometry, helps you calculate angles in polygons, and prepares you for advanced geometric proofs and real-world applications in fields like engineering and architecture. Remember, mathematics builds upon itself. The concepts you've learned today about triangle angles will serve you well as you continue exploring geometry and beyond. Practice these skills, and you'll find that more advanced topics become much more manageable. Thank you for joining me in this mathematical journey. If this video helped clarify triangle angles for you, please give it a thumbs up. Share your questions or suggest topics you'd like to see covered in future videos in the comments below. And don't forget to subscribe for more step-by-step math tutorials that make complex concepts simple and accessible. Keep practicing, stay curious, and remember that every expert was once a beginner. Until next time, happy learning